All right, so I have just a helpful video here walking you through the Unit 7 practice FRQ, and we'll jump into it right away. So here we have our practice FRQ, and we have a motor device right here. It is a device that, when connected to a battery, converts electrical energy into mechanical energy. So essentially, this battery is hooked up to it. It's providing a current coming out of it. It goes across this resistor R1. So we do know that some of the voltage drop is going to happen there, and the rest of the voltage drop is going to happen at the motor. And the motor is now lifting a block of mass M at a constant speed to a height h above the ground at over some time interval delta t. The motor has constant resistance, so we know that this resistor is R1. We can call this motor R2. We can call it whatever we want, but it's connected in series with that resistance of a battery. It's connected in series with that resistance and the battery. So mechanical power, the rate at which mechanical work is being done on the block, increases if the potential difference between the two terminals increases. Okay, so I really like this problem because it's taking us into an application of what could be in a circuit. And essentially it's saying that this motor has some voltage drop across that motor. Now, if that voltage drop increases, meaning it gets more voltage, then the potential difference is going to increase, of course, and that will increase the rate at which the work can be done. So more voltage on the motor, the faster that motor is going to be able to lift that block. And which kind of makes sense, right? If we're thinking about how a motor might work, or how in this case how it spins. So more voltage, just like a battery, or I'm sorry, just like a light bulb. More voltage, the light bulb is going to be brighter. In this case, more voltage, the motor is going to go up faster. So the first part of this problem says determine an expression for the mechanical power of the system here. Now, power, we have a couple different variations of what power is, but really power is the rate at which work is done. It's work over time. And this is coming from us way back from unit 3 with energy, work, and power. So what kind of work is being done by this motor? Well, the work being done is it's giving this block gravitational potential energy. Well, that is just M, G, and H. And I did capitalize M and capitalize H because our variables M and H are also capitalized. So we're just physically pulling things from the setup and calling it good. And which in this case is all we need to do. It's just asking for how much work is being done over a given amount of time, delta t. And you might think, all right, well, what should we do with this? We don't have to do anything with this. This is done, right? This is really simple. It's mgh over delta t. It's a very simple first derivation. First part of this problem is just this nice little derivation. And you get 1 point for saying that powers work over time, and you get 1 point for properly plugging everything in. Well, that seemed pretty easy, right? All right, so now let's get into the bulk of this question, which is the paragraph length response. So our follow-up question states that without M or H being changed, so this M here, that's constant, this H, it's still going to go up to the same height, how can we affect the delta T? How can we make delta T smaller by adding more resistors? So we can add a second resistor. It says that R2 is greater than R1. I'll be honest with you, it really doesn't matter. R2 could be identical to R1, R2 could be less than R1, but the question is, how should the resistor of resistance R2 be added to decrease delta T? So this goes back to kind of where our setup is. How do we decrease delta T? Well, whatever we do, we want to be able to increase the voltage of the motor. So how are we going to do that? Well, if I add a resistor in parallel with the battery, all that means is that I'm putting a resistor right here. Now, that would mean that this voltage drop right here would be equal to the voltage drop of the battery, and the voltage going through the rest of the circuit would also be equal to the voltage drop of the battery, which is going to give me the exact same thing it was before. So that doesn't work. What about in parallel with R1? So if we go up here and we put another resistor right here, well, at that point then, the current would split, okay? So the current's going to split between R1 and R2. R2's right up there. And then it's going to come back together and go to the motor. So we might think then that that might not work because the current's got to split. But the current comes back together. So I have to think then, what happens to the equivalent resistance when I add that in parallel? And anytime I have resistors in parallel, my equivalent resistance is going to go down. So if my equivalent resistance goes down, the current's going to go up, and that will cause this voltage drop to go up. So this is actually the correct answer right here. But let's go ahead and, for our sake, just double check everything else. What about in parallel with the motor? Well, if it's in parallel with the motor, it's going to get the same voltage drop as the motor. It doesn't actually affect it again. And then what about in series with the battery? So let's just say we just add another resistor. It doesn't really matter where. Well, then the equivalent resistance in this case is going to go up, which will make my current go down, which will make my voltage drop go down. So that this one doesn't work either. So in parallel with R1 is our correct answer right here. So guess how many points you get for this? Checking the right box. That is, of course, 0. You don't get any points for checking the right box. But it helps you think about what's going on. So without the rest of this question now is, so we know that it's in parallel with R1. In a clear, coherent paragraph-like response, justify why it decreases delta T. So where do we begin? Well, we need to have something that indicates when I add this resistor in parallel with R1. So let me go ahead and draw this here. And you can draw this. You don't have to draw it. You can use figures to represent or reference them in your explanation. But we have this R2 resistor. And if I add R2 resistor, so if I add R2, I know that equivalent resistance goes down. Therefore, that's the 3 dots that mean therefore. You'll see that a bunch if you ever take a college science or a calculus class. Therefore, my current is going to have to increase. So by resistance, equivalent resistance going down, my current is going to go up because the equivalent resistance of the entire circuit goes down when I add that. Not just the equivalent resistance of that little branch, but the equivalent resistance of the entire circuit. Because before it was R1 plus the resistor of the motor. Now it's R equivalent plus the resistance of the motor, which is going to be less than it initially was. So my current is going to go up. And really, that's the bulk of my explanation. My one little line here is going to really help us out. So how do we put this in words? Well, we know that if I have more voltage, it's going to lead us to the motor working faster, which will give us less time. So we need to say something about, by adding R2 in parallel, the equivalent resistance of the circuit goes down, which will cause the current going through the circuit to go up, which will allow for a larger voltage drop across the motor, which will allow it to raise the block in less time. And putting that into words, which is kind of what I did, but I did it a little fragmented, is going to be everything we need to do. So there are 5 points to this rubric. The first one is for justification that says that the power must increase for delta T to decrease. So power, we know, is work over time, but it is also, in our circuitry case, the current times the voltage drop across that motor. So if then that leads us back, that says that if we can get the current to go up, we can get more power. So if I check the right box that in parallel with R1, the second point is for correct assertion that current increases as the resistance of the circuit decreases. So I said that already, right? I said that right here. And that comes from Ohm's law. If the voltage stays the same and the resistance goes down, that means that the current must go up. The next point is for making the connection that there's an increase in current specifically in the motor. That is also true, right? I said that like the current splits right here, but it all comes back together right here, and it is still a larger current because it's the same as the total current in the circuit and not just the current through those two branches. So that's our third point. Our fourth point, for justification that indicates connecting R2 in parallel with R1 will decrease the equivalent resistance. And I said that already because now we have REQ in parallel. And anytime we have equivalent resistance in parallel, that equivalent resistance will be less than the smallest resistor. So I have that as well, and I said that already, but you need obviously to put that in words. And then our pity point, for a logical, relevant, and internally consistent argument that addresses the required argument or question asked and follows the guidelines described in the published requirements for the paragraph length response. AKA, did you attempt to answer the question in a logical manner without talking about nonsense or stuff that doesn't apply to this circuit, and do so in a paragraph length fashion? So those are the 5 points for this paragraph length response. And let me go ahead and show them to you on the next slide. So here are our 5 points. Our 7 points total. This was the paragraph question. We had the first 2 points were just for that really easy derivation. And then here are the other 5 points, right? For saying that power increases, then the time will decrease. The resistance has to decrease in the circuit. There's an increase in current over the motor because it has the current from the circuit. And if I put R2 in parallel, it'll decrease the resistance, and that will increase the current, and my paragraph length response. So really, the first 2 points, in my opinion, should have been gimme points. That's our basic definition of work over time. The other 5, I mean, if you grab onto that concept of all I have to do is somehow decrease the resistance and increase the current, I mean, it's not outlandish to say that somebody should be able to get all 5 of these points with your exposure to circuits. Now, that being said, I wanted to point out something with you, and that is that the global average for this question is 2.08 points, meaning that if you got these 2 points right here, you are on par with the global average of this problem, which seems crazy, right? It's a very manageable paragraph length response. Like if I saw this one on a paragraph length response, I'd be like, I'd expect to get at least 2 or 3 of these points here, and on top of my 2 points to get like a 5 out of 7 or a 7 out of 7, whatever. So just to give you kind of a quick little score breakdown with this particular exam, if you got 3 out of 7 points, well, 3 out of 7, and that's just getting 1 point out of those in that paragraph length response, you're at a 43%, which puts you right about that in between that 2 and that 3 range. If you can get 5 out of 7 points on this, which is getting the bulk of the explanation, which I think is extremely manageable, guess what? That puts you, for this question at least, at that 5 range. So being able to work yourself through this problem, this very manageable problem, in 12 minutes can really help out your overall score, and can kind of make up for some of those multiple choice questions or one of the other FRQs that maybe had a lot more points and a lot of smaller points. So this is a 7-point question, not a 12-point question. This is a very manageable getting all 7 of those points. So I hope this video helped you out and helped you set up your paragraph. I'm not going to write the paragraph for you, but hopefully it did a lot to help. And as always, if you have any questions, please feel free to let me know.